Welcome everybody to this new lecture of our book Electrodynamics, and today we will continue our discussion about Minkowski diagram. And in our previous lecture we were discussing about this figure that if we have a point on x prime line, that is the point P, and I know the coordinates of this point P in S frame, that is the distance or component of this point P at x-axis is equals to x, and at CT, this axis, at CT axis is CT, so the point of this coordinate in S frame is xct. And I also know that this is an event in S prime frame when t is equals to 0. Okay, then I apply these conditions, and by the use of this geometry I conclude this result giving by equation number 11 is that the distance, or you can say it as the coordinate of this point P in S prime frame is equals to this distance OP and multiplied by this constant factor root 1 minus beta square over 1 plus beta square. Okay, this is the simple logic. If this point is somewhere at this x prime line, here, always measure that line and multiply that line by this common factor, that is this common factor 1 minus beta square over root 1 minus beta square over 1 plus beta square, and you can find that coordinate or that point. Okay, so this is actually the beauty of this Minkowski diagram, to give the same point which has coordinate x and ct in S frame, gives us coordinate in S prime frame given by this x prime coordinate, which is equals to OP, which is the distance of point P from the origin, and multiplied by this factor. And similarly we can do this the same mathematical description for a point which is at the CT prime line, and this is the point Q, which is at this line, CT prime line. And if you want to calculate the coordinate of this point Q, which is situated at CT prime line, and you already know that the coordinate of this point Q in S frame is this CT, and x equals to 0 here. So this CT and this x, this CT and this x, that you know the coordinates of this point in S frame, and you want to know the coordinate of this point in S prime frame, and this time this point is situated at CT prime line. On the other time this point P is situated on X prime line. That is the difference between these two points. Okay, so by Minkowski diagram you can calculate the coordinate of that point Q, which is situated at the CT prime line. The CT prime coordinate of that point is OQ, that is the distance of that point from the origin, and multiplied by the same factor. So this is very easy. If you have any point, here, and here, anywhere on the CT prime line, measure that particular line and multiply the same factor, root 1 minus beta square over 1 plus beta square. You can get that point. Okay, now discuss a journal case. Journal case is that if there is a point P here, look at here, if there is a point P which is situated at a journal position, neither on the x prime line and nor on the ct prime line. Okay, this is a journal position of this point P. Okay, then what is the coordinate of that point P in S prime frame? In S prime frame, you know the coordinate of that point in S frame, because draw a perpendicular here, draw a perpendicular here. This is the coordinate that belongs to x-axis, and draw a perpendicular here. This is the coordinate that belongs to this time axis of S frame. So you know the coordinate of this point at x-axis and ct-axis, that is in S frame, but you want to know the coordinate of this point in S prime frame. In S prime frame. Okay. So what is the strategy behind it? The strategy is that draw a parallel line parallel to ct prime line. Draw a parallel line which is parallel to the ct prime line. And what is ct prime line? Ct prime line is that line at which every point at this line has coordinate x prime is equals to 0. X prime is equals to 0. Okay, so draw a line this line which is parallel to the ct prime line, okay, and look at the coordinate, look at the point where this parallel line from point P to the x prime line is say that this parallel line is meet at x prime line at point B. Then the same method. Measure this OB. This is the coordinate of x prime coordinate of this point in S prime frame. So the method is same. Measure this OB. Measure this length OB here to here, and multiply it by the same factor. Easy trick. Okay, and if you want to know the coordinate of ct prime of that particular point, then draw a parallel line parallel to the x prime line, parallel to this line. Draw a parallel line which is parallel to the x prime line. Okay, and look where it meets at ct prime line. So it meets at ct prime line at point A. Okay, if you want to know the coordinate of point P of ct prime coordinate, you can say it as ct prime coordinate, then draw a line parallel to x prime line. Similarly, when we want to know the coordinate of this point or at x prime line, then we have draw a line parallel to ct prime line, and this time we want to know the coordinate of this point at ct prime line, then we have to draw a parallel line which is parallel to this x prime line, and look where it meet at ct prime line. So it meet the ct prime line at point A, so measure OA and multiply by the same factor. Guys, measure OA and multiplied by the same factor, root 1 minus beta square over 1 plus beta square. This is the beauty of Minkowski diagram. Okay, you can simply change the coordinate using only this factor and a scale factor which used to measure the length in x prime and ct prime axis, or you can say that in s prime frame, and measure only that length, and you can convert the coordinate of s frame into s prime frame and coordinate of s prime frame into s frame simply by this geometrical arrangement only. Okay, so if you want to know the coordinate of this point, the x prime coordinate of this point, then draw a line parallel to ct prime line. And if you want to know the coordinate of ct prime coordinate of this point, then draw a line parallel to x prime line and look where they meet at these axes, or these lines, not axes, these lines, and look at the distance, measure the distance multiplied by this factor, measure the distance multiplied by this factor, gives you the corresponding coordinates of x prime and ct prime, the space coordinate and the time coordinate. Okay, now because tan theta, where this tan theta is equals to beta, which is equals to v by c, since the velocity v is always less than c, because we live in a low velocity world, and which is the velocity v is the velocity by which the frame s prime frame is moving with respect to s frame. Okay, and look at the figure. These all events which happen here, which occur here at this point, at this point, at this point, at this point, these all events has ct prime coordinate equals to 0. That is, this line is the locus of that point which have ct prime, which have actually x prime, sorry, not ct prime, x prime coordinate equal to 0. Because when you move at this line, that x prime is equals to 0 here, x prime is equals to 0 here, and say anything, say that this value is something, x prime this, and then x prime is constant, x prime is constant, x prime is constant, x prime is constant, and here when you move at this line, that is, which is parallel to x prime line, then here ct prime is same, ct prime is same, ct prime is same. That is, for all these points, the ct prime coordinate does not change. That is, it is the locus of that ct prime, a locus of that point for which ct prime coordinate is become constant, and this is the locus of that point for which the x prime coordinate does not change. Okay, and the method is this. For calculating the s prime coordinates, you can say it as s prime coordinates of this point, method is this, as suggested by the Minkowski geometrical diagram. Okay, now because v is always less than c, which means beta is always less than 1, which means beta is always less than 1. Okay, for you, because this is the relation between theta, beta and v by c. Because v is less than c, that's why beta is less than 1, and that's why tan theta is less than 1. Because beta is less than 1 and beta is equals to tan theta, so tan theta is always less than 1, and we can write this relation that tan theta is less than tan pi by 4, because tan pi by 4 has value 1, which means then that the theta, this angle theta, this is measured from the x-axis and this is measured from the ct axis, is always less than pi by 4. always less than pi by 4. Never cross this limit. Never cross this limit. Theta is always less than pi by 4. If we increase this velocity, that is the velocity of frame S prime, if we increase this velocity by which the frame S prime is moving with respect to frame S, then we have some other X prime line and some other CT prime line, but no line is there for which theta is greater than or equal to pi by 4. There is no line. There should be no line for which theta is equal to or greater than pi by 4. Theta is always less than pi by 4. This is the condition for this type of diagram. Because V is less than C. V is always less than C. When we say that we are in the relativistic limits, in the relativistic, that is when we are talking about the particle like photon, then we can say that okay, this is V is equals to C. But this is when we live in this material world, okay, where material particle is moving with the velocity which have minimum 5%, 10% or maximum 20% of light, maximum 20% of light speed of light. Okay, so because we live in this material world and material particle does not have the velocity of equal to the velocity of light, so V is always less than C. V is always less than C. Okay, until we start talking about relativistic limits, and because we live in this world and there is no relativistic limits in this world, there is no particle or no device is moving with a speed comparable to the speed of light. Okay, so V is always less than C, and which suggests that angle beta, this beta, not angle, it's a constant which is the ratio of V by C. So beta is always less than C, and that's why tan theta is always less than C, because theta has value 1 in its angle pi by 4. So tan theta is always less than pi by 4 and theta is always less than pi by 4. This is the consequences between these quantities. And if we increase the velocity, this results in increasing the value of theta, but theta is always less than pi by 4. It's always less than pi by 4. Okay, and we can get some other new X prime line and CT prime line, but the condition is, until the condition, this condition is followed, we can get the new X prime and new CT prime lines like these. This is the X prime, one X prime line, new X prime line, other possibility of X prime line until this angle theta, is less than pi by 4. We have a number of X prime and CT prime lines. As the velocity, this velocity is increase. Okay, and always respect this relation. Theta is always less than pi by 4. Then we can get other X prime and CT prime line. Okay. Now talking about a new concept, and this is also related to Minkowski diagram, and this is about the relativity of simultaneity. Relativity of simultaneity. Okay, what is relativity of simultaneity? The relativity of simultaneity suggests us that if two events is simultaneous in one frame, which occurring at different points in one frame, okay, simultaneous, okay, the simultaneous events are those events which occurring at different different points or places in one frame, but at same time, but time is same. Okay, so these events, those events are known as simultaneous event, and we are talking about relativity of simultaneity. And this theory suggests us that if two events are simultaneous in one frame, which occurring at different points in that frame, is not simultaneous in other frame, and these frames are inertial frames. Okay, inertial frames which followed by the first law of Newton's law of motion. So this is the relativity of simultaneity. That is, if two events occurring in one frame at different places are simultaneous in that frame, are not simultaneous in other frame. Let's check it. Okay, so this is two events which are simultaneous in one frame occurring at different points are not simultaneous in other frame, and these frames are inertial frames. Okay, so because at the start of this topic we decide that we are always talking about the whole theory about inertial frames, not talking about the non-inertial frame. That is the different theory. So let us consider two events at point P1 and P2 in S frame, okay, which are simultaneous occurring in S frame. ये मेरे पास दो points हैं, which are simultaneous in S frame, not S prime, S frame, which are simultaneous in S frame. Okay, I draw this diagram like this. Okay, look at here. This is my x-axis, which is the representative axis of the three mutually perpendicular axes, x, y, and z, and this is my CT axis, the time axis, and this method is suggested by Minkowski, and this is known as space-time diagram. This axis suggested me the space coordinate, and this axis suggested me the time coordinate. That's why this is known as space-time diagram. Okay, and here is my x prime line, and at the same angle, may be different, but for the time being, this is my CT prime line. This angle is theta. This angle is theta. Oh. And we have two events. This is first point, which is the first event occurring at this point, and the second event is occurring at this point. Okay, we have 2 points which are simultaneous in S frame. Okay, and we deduce that these points are not simultaneous in S prime frame, and these are the coordinates of S prime frame, X prime line and CT prime line. I don't use the word for these X prime and CT prime as axis, because they are not fixed. These are moving, or can rotate, or can move with respect to this theta. Okay, if theta increase, X prime line increase, CT prime line increase. The inclination of these lines, X prime and CT prime, with respect to X and CT, is increased as the theta is increased. That's why I use the word line for these X prime and CT prime, not axis. Okay, and because these are fixed, X city. Okay. So I use the word axis for these two, X and city. Okay, and I deduce that these are simultaneous in S frame. These two events are simultaneous in S frame. Okay, I write here is that P1, P2 are simultaneous in S frame, and I want to deduce that these events occurring at point P1 and P2 simultaneously are not simultaneous in S prime frame, are not simultaneous in S, and simultaneous events are those events which occurring at different point but at the same time in one frame. Different points, same time. Those events are called as simultaneous event. Okay, so what is the CT prime coordinates of these two axes? Okay, so let us what is the CT prime coordinate of these two events or these 2 points, you can say it. What is the CT prime coordinate? And I tell you that if you want to here this is the general case. If you want to know the coordinate of this point, whether you want to know the X prime coordinate or CT prime coordinate, if you want to know the CT prime coordinate, then draw a line parallel to X prime line, this line parallel to X prime line, and you know the coordinate OA multiplied by this factor of this point. This is the CT, this is the CT prime coordinate of this point P, this point P. This is the CT prime coordinate of this point. Okay, and look at here. This I want to know the CT prime coordinate of these two events. CT prime coordinate. Okay, then what I can do here is that and draw a line parallel to this X prime line. Draw a line parallel to this X prime line. Look at here. Then draw a line parallel to this X prime line. Okay, so here I draw a line parallel to this X prime line, and say this point is Q1. Okay, and draw a line. Then what is the coordinate of this CT prime coordinate of this point P1? So I write here I write here is CT1 prime. That is the CT prime coordinate of this point in frame S prime. I know already the coordinate of this point in X frame, in S frame. Why? Because draw a perpendicular here, draw a perpendicular here. So this is the coordinate, X coordinate of this point in S frame, and this is the CT coordinate of this point in S frame. But I want to know the coordinate of this point in S prime frame, and I want to deduce here that these points are not simultaneous in S frame, which is simultaneous in S frame. Okay, so let's do this. So say this is the origin O, which is the origin of S frame. So what is the CT prime 1? That is the coordinate of this CT prime coordinate of this point P1. So draw a line parallel to this line, parallel to this X prime line. Draw a line and say this point is Q1. This point is Q1. So method is that measure OQ1. Measure OQ1. Okay, measuring, and multiplied by the factor 1 minus beta square over 1 plus beta square. Okay, this is the CT prime coordinate of this event which occurring at point P1 in S prime frame. Now I want to know the coordinate, CT prime coordinate of this point P, or this event which occurring at this point P2. Then what is the coordinate of this point P2 in S prime frame, the CT prime coordinate? Okay, the method is same. Draw a line parallel to this X prime line. Draw a line parallel to this X prime line, and say this point is Q2, this point is Q2, and measure OQ2. So CT prime 2 for this coordinate P, this point P2 is the event which occurring at this point P2. So CT2 prime is equals to measure OQ2, and multiplied by the same factor 1 minus beta square over 1 plus beta square. Yes. But OQ1 does not equals to OQ2. OQ1 does not equal to, look at here, OQ1 is this distance from here to the origin, and OQ2 is distance from here, this point Q2 to this origin O. OQ1 is this length, OQ1, and OQ2 is this length. So OQ1 is not equal to OQ2. Hence this results in that CT prime 1 does not equal to CT prime 2, or you can say it that T1 prime does not equal to T2 prime coordinates. That time is not equal. And for simultaneous events, time must be equal. Places are different, but time is same. But look at here, time is not equal for these events in S prime frame. Okay, so this is the relativity of simultaneity. Okay, the two events which are simultaneous in one frame occurring at different points are not simultaneous in other frame. Okay, so this is the beauty of this Minkowski diagram, and by the help of this Minkowski diagram we can derive this result. Okay, now talking about one more example here, that this is my CT axis, this is my x axis, x representative axis, this is my time axis, CT axis, and similarly this is my x prime line, this is my CT prime line. Okay, this angle is theta, this angle is also theta. Okay, I deduced this result already, and there are 2 points. These are 2 points, P1 and P2. These are 2 points which are simultaneous in S prime frame. Now in this case these are two points, and events occurring at these 2 points are simultaneous in S prime frame. In our previous example, there are 2 points which are simultaneous in S frame. These are 2 points which are simultaneous in S prime frame. And I want to deduce that these events are not simultaneous in S frame. These are not simultaneous in S frame. Okay, so the method is same. So draw a line parallel to x-axis. Draw a line parallel to x-axis gives you the CT coordinate of this point. This is our origin O. And measure this length. Say this is point Q1. So measure this length OQ1. Okay, so this length OQ1 is simple. Oh, sorry, not OQ1. This is my coordinate CT1. I write it as CT1. Okay, and CT1 coordinate for this point is OQ1 and multiplied by the same factor, 1 minus beta square over 1 plus beta square. This. Then now I want to know the CT prime coordinate of this point P. So draw a perpendicular, draw a line actually, which is parallel to this x prime line. So measure CT1 now, CT2 now. So CT2 is, say this point is Q2. So CTQ2 is OQ2 and multiplied by the same factor, 1 minus beta square over 1 plus beta square, square root of this. And again, OQ1 does not equal to OQ2, which implies that CT1 does not equal to CT2, which implies that T1 does not equal to T2. OQ1, measure this length O to Q1 here to here, and measure this length O to Q2. Okay, so these are different lengths. Okay, so you can say it as those events which are simultaneously occurring in S prime frame does not simultaneously occur in S frame, and the reverse is also true. So this is the relativity of simultaneity. Okay, relativity of simultaneity. That means the two events which are simultaneous in one frame occurring at different points are not simultaneous in other inertial frame. Okay, so this is the discussion about relativity of simultaneity. Okay, and we deduce these results. Okay. These are the same calculation as we do on the rough paper. This is the same calculation. Okay, these are the same calculation. So now the two events which are I discussed here, that the two events which are simultaneous in one frame occurring at different points are not simultaneously occur in other frame. Okay, now talking about some new concept related to the same topic, Minkowski diagram, and draw a line P1 P2. Okay, look at this diagram. This is very horse diagram, and I try to draw it for you separately. This is very horse diagram, but I draw it for you separately on the rough paper. Okay, but try to understand something, some concept about this diagram. Okay, so this diagram consists the 2 points, same 2 points, P1 P2. Okay, but the line joining the P1, P2, that is line P1, P2, is purposely drawn so that this line, if you able to see that this line P1, P2, this line P1, this point is P1, this point is P2, this line P1, P2 is purposely drawn that it makes an angle greater than 45 degree. This angle is greater than 45 degree by this axis X of S frame. Purposely draw. Okay, and because this line is making an angle greater than 45 degree, can we find a frame in which these two events which occurring at these two different points P1 and P2 are simultaneous? Can we find a frame in S prime frame which is parallel to this line? Can we find a frame like this? Okay, so try to understand this. Now if we increase theta, this is my X prime line and this is my CT prime line, okay, and if we increase this angle theta, okay, then we find some other X prime and new CT prime lines. Okay, so this is new X prime line, dotted line, and this is new CT prime line. Okay, and I know the condition. Condition is that this theta does not equal to or greater than pi by 4. I discussed it earlier that this angle theta does not equal to or greater than pi by 4. So if I draw the line, this line X prime line, and I know that this angle does not equal to or greater than pi by 4, then there is no line which is parallel to this P1 P2 line. Draw a line here, draw a line here, draw a line here, draw a line for different theta, and remember that condition, that theta does not equal to or greater than pi by 4, then you cannot find a line, or you can say that you can find a frame for which this line P1 P2 is parallel to any X prime line. So there is no line such frame for which this line P1 P2 is parallel to any frame. There is no frame. So if the slope of P1 P2, this line, if the slope of this line, which is always greater than 45 degree, and purposely I purposely draw it, not incidentally, but purposely draw it. So if P1 P2, the slope of P1 P2 is greater than 1, and when it happens that the slope of P1 P2 is greater than 45 degree, then there is no frame in which these two events occurring at these two different points P1 P2 are simultaneous. That means CT1 prime make a line parallel to this X prime line. So P1, if you want to find the CT prime coordinate of this event P1, then draw a line parallel to this axis X prime line. So this is your line, and this is time T1 prime, and draw a line parallel to this same line, x prime line. Then this is point, and this is your time T2, and this is your coordinate CT2 prime. Then there is no line, there is no frame in which these events are simultaneous. That means that this time T1 does not equal to T2, because if these events which are occurring at these two different points are simultaneous, then T1 should be equal to T2 prime. T1 prime should be equal to T2 prime. Okay, and in frame S, there is, I talked it about S prime frame, and if I talked about the S frame, in S frame, what is the coordinates of these two events? Okay, so if I draw a line, this perpendicular line to this x-axis, this is my x-axis, this is my x-axis. Okay, so draw a line from P1 perpendicularly on x-axis, and draw also a line from P2. This is my x2 line. Okay, so this line, this point is P. So P1 P coordinate, that is the x coordinate of this is x1, x2 minus x1, and this length is, if I draw a line from P2 to this CT axis, so this line is meet as T2, and if I draw a line from P1 to this CT axis, this meets it as T1. So this length is equals to C T2 minus T1. Okay, so I draw it separately on the rough paper for you. Look at here. Look at here. This is the case. This is my x prime line, or sorry, not x prime. It's my x representative x-axis, you can say it. This is my representative x-axis, and representative x-axis, and this is my CT axis. This is my CT axis, and this is the line x prime line, which I say it as x prime line, and this angle is theta. Also there is a line here. There is a line here. I say it as CT prime line. So here is events. This is point P1. This is point P2. And the line joining these 2 points makes an angle greater than 45 degree by this axis x. So I purposely draw it as this. So if I draw here this line parallel to the x-axis line, so this angle is always greater than 45 degree. So if I increase this angle theta, and I find some new x prime line, say here, and here, and the condition is that this theta does not equal to or greater than pi by 4. Okay, the condition is same. So there is no, and the same slope of this line. This is new CT prime line. This is new CT prime line. The same converging. You can see it as converging phenomena. If the angle is theta is increased, then x prime line goes upward, and the CT prime line goes downward. Okay. So this is converging like phenomena. So if this angle is 45 degree, greater than 45 degree, then there is no frame such that these two events are simultaneous to each other. These two events are simultaneous. How can I prove it? I proved it that if I want to know the CT prime coordinate of these 2 points, then draw a line parallel to x prime line. So draw a line here. Draw a line here. which is parallel to this x prime line. Okay, and this is my CT1 prime coordinate. Okay, and if I want to know the CT prime coordinate of this event occurring at this point P2, then draw a line parallel to this x prime line, and you can find the point and find the coordinate of CT2. This is my CT2 prime coordinate. Okay, and you know that because there is no frame, such frame in which this line P1 P2 is parallel to some line x prime line, so these events are not simultaneous in this frame, S prime frame. There is no frame in S prime frame for which these two events occurring at these two different points P1 and P2 are simultaneous. And if these are not simultaneous, and you can say check it by this, that C1 by this, say this is the origin O, then CT1 prime does not equal to CT2 prime. Look at here. Look at this coordinate. Okay, because the method is same. Say this point is Q1, this point is Q2, then what is CT1 prime? Is OQ1 multiplied by the same factor, root 1 minus beta square over 1 plus beta square. And this is, say this is Q2. So measure this OQ2 and multiply it by the same factor, root 1 minus beta square over 1 plus beta square, and you can measure this CT2. And finally, you know that OQ2 does not equal to OQ1. So CT1 does not equal to CT2, and you can say as T1 prime does not equal to T2 prime. Yes. T1 prime does not equal to T2 prime. That means there is no frame in S prime frame in which these two events are simultaneous to each other. Okay, and now I want to know the fact that these two events are simultaneous in S frame. So for this I want to know the coordinates of these two events in S frame. So look at here. So draw a line perpendicular to this axis X. Say this coordinate is X1, and draw a line from here, from there, this, and say this coordinate is X2. Say this coordinate is X2. Then this difference is, say this point is P. This point is P. This point is P. Then this difference, that is P1P, P1 is equal to X2 minus X1. This distance. Okay, and this, draw a perpendicular from here to point this is my CT2, and draw a perpendicular line from P1. This is my CT1. Okay, so this distance between the point P and P2, this is CT2 minus CT1. I now want to know, or try to know, that I already deduced this result, that these two events are not simultaneous in S prime frame, and I now try to deduce the result that are these two events are simultaneous in S frame or not. Okay, so from figure you can easily deduce that this distance P2 is greater than this distance P1 if this slope is greater than 45 degree. This condition is always maintained. If this slope is greater than 45 degree, then this length CT21 minus CT1, that is the difference between P and P2, is always greater than this distance P1 P, that is equal to x2 minus x1. Hence, if this slope is greater than 45 degree, then this distance T21 minus CT1, that is the difference between P and P2, is always greater than the distance between P and P1. Is always greater than. Okay, and from above condition, it is followed that then there is no two events which are simultaneous. From this result, I deduce that CT2 minus CT1 is always greater than x2 minus x1, and if this condition were followed, there is no such frame in S coordinate for which these two events are occurring simultaneously. Okay, and such pair of events for this condition is followed. Such pair of events for which this condition is followed are known as time-like events. Time-like events. Why time-like? Because time is different. Because why time-like? Because these events are known as time-like events. These events for which this condition is followed, that CT21 minus CT1 is greater than x2 minus x1. This condition is followed, then these events are known as time-like events. Why time-like? Because space coordinates are same for these two events, but the time coordinate are not. Space coordinate is same, but time coordinate is different. These two events, for this condition is occurred, these events are called as time-like events. Okay, so that's all for now, and meet you into the next one. Thank you.